So today is a dreadful date in American history, as I'm sure you know. It is 9/11, and today we are classifying polynomials. And you guys have, I think, all taken geometry. So I think by the time you reach junior, senior level, that's like a prerequisite is that you've taken that class, right? And you might remember in Mr. Manlove's class that if he gave you a triangle, you had to classify it two different ways. So you might have said like, oh, it has all angles less than 90 degrees, so I'm going to call it acute. And then you're like, oh, it has two sides the same, so I'm going to call it isosceles. And then when he had you classify that triangle, you would have called it an acute isosceles triangle. Does that ring any bells? Or if it had one angle that was really fat and then all the sides were different, you would call it an obtuse scalene triangle, right? Obtuse meaning it's got one obtuse angle, scalene meaning all the sides are different. What we're going to do today is kind of cut from that same cloth. We're going to have two ways in which we classify our polynomials, and one of them is by its degree, and the other is by its number of terms. And this will make complete sense in about 11 minutes. So that's the idea. So let's get to it. So let's talk degree first. So the degree of a polynomial is the highest, it's defined by the highest exponent of a variable. So, for example, well, here, let me give you a little definition here real quick. So let's write that down. Highest exponent on a variable. It has to be on a variable. So like if you had just a number 2 and raised it to the 10th power, that doesn't count towards degree. Degree has to come from a variable. So for example, if I gave you a polynomial like x squared minus 3x plus 10, what is the highest power of x that you see in this problem? Take it out. Always out. Always out. It is 2. So this 2 being the highest power of x tells me that this polynomial has a degree of 2. And we have a name for that, and that's going to be today's lesson, is really to get to what is it called if the degree is 2. How about this polynomial? What's his degree? 4. Because I spy that on the variable x, he has a highest power of 4. So this time I would say that the degree is 4. Any questions about what degree is? Okay. The other method of classification is not the degree, but the number of terms. And the terms, I can give you a little bit of a half-hearted definition for this. The terms are separated by plus and minus. So that's how you can tell in a polynomial expression when you encounter a new term, like, and I'll show you what I mean. You can have a chunk of math that's attached by times, but as soon as you put like plus, then whatever comes after that, you start a whole new term. And so, for example, let's do 4x squared plus 11x. How many terms does that have? Very good. So we would say that this one has 2 terms. One of the terms, I'll circle it, I'll put a box around it, is 4x squared. And then the other term is 11x. And you see exactly what I mean. They're separated by the verb plus. How about this one? Say again? It has three terms. Good. And we can make these look as confusing and weird as we want to. And at the end of the day, if you understand the definition of what a term is, then you understand that there's, here it goes, chunk of junk minus chunk of junk plus chunk of junk. And the fact that there are chunk, chunk, good job, tough, that means there are exactly three terms. So are you all clear on what the degree of a polynomial means and what the number of terms is all about? Okay, then let's get to it. For the next part of our notes, we're going to make kind of like, we'll wind up making two sections. And I'm not a geometry teacher, but I would equate this to the part of the lesson where I would tell my students, okay, on this side of your paper, we're going to classify the triangle based on its angles, like acute, right, obtuse, stuff like that. And then on the other side, we're going to classify by the number of sides that it has the same. No sides the same, scalene, two sides the same, isosceles. What do we call it if all three sides are the same? Triangle, all three sides the same. Put it away, put it away, put it away, all the way away. Get it gone. I don't want it in your lap. Put it away, backpack. Equilateral, very good. So this is kind of how that goes, is we're going to classify polynomials now by their degree. That's going to go on this side of my paper. And then on the other side of this curtain, we're going to classify a polynomial by its number of terms. And when we're done, every polynomial I give you, you should be able to classify it using both methods, like back to back, just like we do with triangles. Right scalene, obtuse isosceles. So here we go. From the ground up, you're going to be asked to know what these are, whether they're in your notes or you memorize them. It helps if you memorize them. A polynomial can have a degree of 0. And that means that there really are no variables at all. That would mean that if someone put a gun to your head and said, prove to me that there's a variable in there, you'd have to put like x to the power of 0 just to show that it's there, but it's not really there. Does anybody know what a polynomial is called if it has a degree of 0? No. It's called a constant. It's called a constant, and I'll show you why. Because something like in English that is constant, we say never changes, right? And the same can be said of, let me give you some examples of constants. You ready? I'm going to write them in red. -4. Do you see the variable attached to the -4? You probably don't, do you? But again, if someone walked in here and put a gun to my head and said, prove to me that that's a degree of 0, I'd say, fine, done. Put the gun away. Because what is x to the power of 0? No, it's not 0. It's 1. Anything to the power of 0 equals 1. And so I could prove to somebody that, hey, there is a variable, but it has a power of 0. And when something has a power of 0, it's pointless. And so for that reason, this is called a constant. It will never change. -4 is always going to be -4. He doesn't have any variables to make him ever vary or change, right? Another example of a constant, 2/3. Another example, 0. Another example, -10. You get the idea? A constant is merely a number. Now let's get to the good stuff. If a polynomial has a degree of 1, anyone know what that one's called? These are called linear. Because if you graph them, they make straight lines. So to be a linear, you have to have a degree of 1. And this is another one of those times in math where there's something there that you don't actually see. So an example of a linear polynomial would be something like 5x plus 2. Y'all see the variable, right? And do you all see his exponent? What is it? What is the exponent on my variable? It is 1. I can't say 0 this time because 0 would mean it's not really there, but a 1 means there is x to the power of 1. There's like 1x here. So anything that just has a regular variable with an exponent that you can't see, we call a linear polynomial. Could you give me another example of a linear polynomial? Sure, I'll take it. 6x plus 8. How about this one? How about negative 5m minus 2? How about this one? Negative 10x. We could do this all day. At the end of the day, if you give me something that has a variable with no visible exponent, it is a linear polynomial. Got it? So far we have 0 is constant, 1 is linear, and I'm going to erase a bunch of stuff now. And I'm going to head on down to 2. Does anyone know what a second degree polynomial is called? Nope, that will be a word that we use later. If the degree is 2, we call it a quadratic. Could someone give me an example of a quadratic polynomial? I love it. That is a gorgeous quadratic polynomial. It's got, I love that quadratic. How about this one? Negative 4.6x squared plus 134x minus 12. Is that a quadratic? It meets the definition. Yes, its highest power of x is 2. So it's a quadratic. Any questions about that one? All right, the next one up is 3. Does anyone know what 3 is called? This, by the way, is way less boring if you actually try to answer questions. Say again? The try that you're thinking of, can you stop clinking that water bottle? It's going to make me want to punch a baby. You just have to stop. Thank you. I wish they made water bottles that weren't so flimsy, but that sound is, oh God, Lord, that's bad. Try is for something else. Just trying to come up with like a hint. What shape would you say this is? Cube. There you go, cube, because it's got 1, 2, 3 dimensions. So anything that's got a power or a degree, excuse me, of 3 is called a cubic. Could someone give me an example of a cubic polynomial? It's 7x cubed plus 2. That's a cubic because I spy an x with a power of 3. That's the highest power of x that I see. How about negative 46x squared plus 10x cubed minus 41.9? Is that a cubic? Yes. Yes, it is. It's in a terrible order, which we will talk about in a little while. But boom, it's got a highest power of 3. It's a cubic. Say it again, Tef. Is that it? I'll take it. That's a cubic. Still good? We could do that all day. Don't want to, right? You get the idea. So degree of 3, we use the word cubic. We do have a name for degree of 4. Anyone know this one? It takes 4 of these to make a gallon. The 4th degree polynomial is called a quartic. Go ahead. We just say x to the 4th. Yep. The only time you use fancy words is if someone says this, you can say x squared, or this, you can say x cubed. Everything else is just x to the 4th, x to the 5th. There's really no fancy way to say it. So actually, there probably is, but I don't know what it is. Is that your whole quartic? I'll take it. I can modify Dalton's answer and put like a plus 2x squared plus 94x minus 1. As long as I don't go up and over that x to the 4th, it's still a quartic, right? And it's got, yes, 4 terms. I agree. One more, and that is the 5th degree. And this one is a little bit harder for people just to naturally come up with. It is called a quintic. Very good. Well played. And a quintic, as you would imagine, is just any, as long as the highest power of the variable is 5, specifically 5. And so again, to keep things simple, you could do negative 12 x to the 5th quintic. You want to quintic, so on and so forth. As long as it's x to the fifth, not 18 to the fifth. And by the way, for the record, if I put this down, is that a quintic, 4 to the fifth? It is not. Why not? Because it's not on a variable. Right, that's just a constant because it's just a number. There are no x's. So after this, we stop using words for this. After 5, we do not use words. There are words: sextic, heptic, octic, nonic, decic, undecic, dodecic, so on and so forth. We don't use them after 5. We just stop. So 5 is quintic. After that, anything 6 and beyond, so like 6, we just call 6th degree. It's just that we don't encounter a lot of polynomials beyond 5th degree, which is why we choose not to go all fancy-pantsy on them. But we want to use constant, linear, quadratic, cubic, quartic, quintic whenever we see them. But beyond 5, we just bail out. So like if I gave you, like, I don't know, 13 as the highest power of x, what would you say? It's just 13th degree. Clear? So there comes a point of bailout. You're required to use the fancy nerd talk up through 5, and after that, you just bail. Diedrich, you still with us, buddy? All right, good. So those are our degrees. Let's head to the other side of the curtain now and talk about number of terms. First off, a polynomial cannot have 0 flipping terms or it won't exist, right? So that doesn't make sense. It made sense for degree, but it doesn't make sense for number of terms. The smallest number of terms that a polynomial can have is 1. Anyone know what that's called? Constant. No, constant is when constant has nothing to do with the number of terms. Constant is I have no variables. Linear. Nope. Linear. All the words we've already used, we will not use again. It's not a bad guess. It's actually called a monomial. So if a polynomial has just one term, regardless of its degree, like this, how many terms does that have? It's a monomial. It's an 8th degree monomial, mind you. How about this one? Negative 12 plus x. Is that a monomial? It is not. It's got 2 terms. Negative 12 is a term. X is a term. That is not a monomial. So to be a monomial, you just have to have one term, one chunk. No pluses, no minuses. How about 2? 2 is a binomial. Very good. We will be using this word a lot, binomial, in the next couple of weeks. A binomial has 2 terms. As long as it's got one plus or minus in it, then that's going to be the separation that we need to create 2 chunks of junk. Sure, 3x plus 7. Perfect binomial. How about 11 minus 46x to the 10th? That's a binomial. It's got 2 terms. And there's only one more that we classify. This section or side of your notes is going to be much shorter than the other section because over there we had constant, linear, quadratic, cubic, quartic, good God. And over here we only have 3. What's the 3? Trinomial. Very good. So 3 is trinomial. Very good. And again, it don't get too fancy when you think about this. Bottom line is you just need 3 terms. Okay, 18x is a great first term. Okay, plus 7. Minus, you can't do minus 3. Here's a big brain question for you. Why is that actually not a trinomial? Okay, could you make a case that there are 3 terms in what Tuff said? Right? But what's wrong? Nope, this has nothing to do with exponents. This side of our notes, I don't care about cubes and squares. That was the other side of the notes. This side of the notes is all about how many terms. And you're right to think that this has 1, 2, 3 terms. What's the problem with 2 of these terms? The 7 and the 3 would go together, making what Tuff gave me actually be a binomial. Got it? Now, if I wanted to take Tufts' answer and modify it to actually make it a proper trinomial, you ready for this? I could just go, done. Because now the 7 and the 3 can't go together. It is a proper trinomial. Do I notice something?
Oh my.
Wow. I want to give you extra credit just for observing that. I think I might. Remind me on this first quiz. I'm gonna chop up your grade, just a little boost.
They just look like numbers.
After 3, we do not name them in any particular way. So if a polynomial has 4 terms, we just say with 4 terms. And that happens on down the line for if it has 5 terms or 6 terms or 7 terms. If you would like to research this in your own time, I'm sure you could get on like Wikipedia and find all the proper names for the longer polynomials and the higher powered. Totally up to you. But as far as being your algebra teacher guy, I am responsible for, do you know up through quintic for degree, and do you know up through trinomial for number of terms? So now let's practice. What we're going to do now is we're going to practice classifying polynomials. And your answers should come out in 2 parts: degree, number of terms. And please don't blurt, because there might be others who it takes a little bit longer to process perhaps what this is. So I'm going to write it down. And I want you to conjure up what you think the answer is. Again, it should come in 2 parts. Basically, you pick a word from the first section of notes, commit to it, and then pick a word from the second section of notes, and then you say them back to back. That's enough time, I think. Tough? That is perfect. This is a quadratic trinomial. Nice to, good job. How about (18 minus 5x to the 4th? Aubrey, I'm going to get you here in a second. I want to make sure, again, everyone has a chance to process. I didn't get you last time, and then Dalton, I'll get you on the third one, okay? So this one's, Aubrey's got the dibs on it. I'm ready for you, Aubrey. What do you think it is? Good job. It is a quartic binomial. Well played. Okay, let's go again. What happened to my little toolbar thing? Do you notice that it's gone? It's really freaking me out, like it's gone. Let me see if I can make it come back. Hold on a second. Oh, that was something else. Let me see if I can. Where'd it go? That's really freaking me out, dude. Yeah, like it's supposed to be down here at the bottom of the page. Where? Everybody good? Dalton, this one is yours, because you see I'm supposed to have this little hand thing that I can grab and move the board with. I'll just reboot it here in a little bit. I'll just keep making new pages. Take that, open board. All right, Dalton, you ready? Yeah. Quintic, well played, sir, because it's 5th degree. Monomial, because it's just got the 1 term, no pluses and minuses. Okay, how about this one? Peyton? It is, you got the 4 terms part, you nailed it, but this one actually is a cubic, because the highest power on the x is a 3.
Oh, so I just
Always the highest power. Right. I'm glad you said that because I noticed you were trying to connect the two during when I was talking. What its highest power is and how many there are have no correlation. Good job. Yes. So the highest power of x is 3. So it's a cubic. And then Peyton, yes, 1, 2, 3, 4. So we say a cubic with 4 terms. Everybody okay? All right. I know you're getting bored of this, and I get it. There's one last part, and that is that we have to put things in the correct order. So the last part of this lesson is to get you to understand something called standard form. From this point on, my expectation is that you will write all of your polynomials in standard form. And standard form is, well, it's how you would want someone to write them for you. So you don't want to go digging and looking through and picking out parts and pieces. So standard form is where we start with the first term has the highest variable exponent, and then we scaffold and staircase our way down. It is not chaotic. It's not disorganized. When I ask you guys to put things in standard form, Haley and Aiden ought to get the exact same order. Like this isn't like freestyling where you put them however you like. So standard form, you could put in your notes like highest exponent down to lowest exponent. And that is as we work our way from left to right. So that is what standard form is all about. And none of this stuff that we're learning today is super mathematically important in and of itself. What it does, though, is it makes us more functional and conversationally functional mathematicians over the next however many weeks and months. And that if I say, hey, pick me a quadratic trinomial, then you know exactly what I'm talking about. So here's an example of a polynomial that is not in standard form. You can see right away that it's a little bit fishy, right? So which term do we wish was in the front? That is not a 3x squared. That is a negative 3x squared. So what we're going to do is we're going to relocate that bad boy over there so that he says, let me take the lead on this one because I got the x squared. I'll go first. So in standard form, it's negative 3x squared. And then what? Plus 5x. Now it's in standard form. Look at those beautiful exponents go from 2 to 1 to none, just like we want. Staircasing our way down. Let me give you another one that is not in standard form, and you can help me fix it. Let's go with 12 minus 15 x to the fourth minus 2 x squared minus x to the third. Your assignment today, by the way, because I've already put one to sleep, your assignment today is going to be to classify the polynomials after you've put them in standard form. So job 1, write it the correct way. Job 2, classify it based on that. Which term should lead the way? Negative 15x to the fourth says, hey, let me hop out in front. No signs changing. All we're doing at this point is just moving things around, really. We're not even really doing any math. We're just reorganizing. Who's after that? Yeah, after that.
And then the negative x is negative.
And then the negative 2x squared.
And
then the plus 12.
Wait. I wrote this down.
And again, you'll know you've done a good job when you can see those beautiful exponents 4, 3, 2, none. We skipped a term, but that's okay. They don't have to have them all as long as they go in order. We're good to go. Good. So again, the job is to write in standard form and then classify by degree and number of terms. And your assignment is on Canvas. I don't know if I don't think I've actually published it yet. Let me stop this recording. Actually, let me keep the recording going so we can do a couple of problems together. Let's see, show desktop. Go to Canvas, dashboard, intermediate, 9/11, It's not published module and all items. Yeah, baby. So if you go to Canvas now, you'll find the assignment there. Assignment number 4, PDF. Yeah, this is going to be super easy though. Even if you have to go and take it home, you can either do it tonight or you can work on it tomorrow. This whole assignment should take you 12, 12, 15 minutes. Yeah. All right, let's get to it. So let me zoom in on this a little bit. We're going to do let's do like 4 or 5 problems together. Sound good? I'm going to press on, so I'm not going to stop what I'm doing because of this. So here it goes. Problem 1. How would I write that in standard form? Trinity, it very much already is in standard form. So I can skip that part of the problem. And what would I classify this as? It is a quartic. Keep going. Monomial. It is a quartic monomial. Jackpot. Okay. Number 2, I need to first write it in standard form. And this one is not already in standard form. Nice job, Tough. Negative 10r jumps to the front, minus 5 jumps to the back. Now we got standard form. Oh, no, you don't have to. No. Great question. You guys don't have to copy the original problem onto your notebook paper, just the standard form answer and the classification. What would this one be classified as? A linear binomial. Well played. All right, let's head down to number 3. Shreya, what would be the first term for my standard form? Right, but that's not what I'm after right now. You're right, and it will eventually be a quintic there, kiddo. But what I want to know right now is just what term goes to the front first, because I got to rearrange stuff. Who goes to the front?
Negative 5p.
Gorgeous. Negative 5p to the 5th. And who follows him up? Say it again.
Positive 2.
So plus 2p to the 4th. And then who is... There you go. Now that is part of your answer, everybody. That's writing a polynomial in standard form. And how would we classify this one, Shreya? You were about to help me with that. What were you going to call it? Perfect. And those words come from completely different places. The quintic comes from giving a hoot about the highest power. The trinomial comes from giving a hoot about how many terms he has. Well played. Everybody okay so far? Aiden, could you help me with that number 4? I need to put that in order. That thing's a goddamn mess. So n to the 7th plus n to the 5th. Yep. Gorgeous. And now that we've got it in a beautiful standard form, Aiden, how would you classify this? So in order, we want to do degree first. So we're going to say this is a 7th degree with 5 terms. I don't like those ones. They're really boring. Like when I don't get to use my fancy nerd words, but it is what it is. Thanks, Aiden, for the help there. All right, I'm going to erase some stuff. Let's head down to problem number 5. Haley, tell me about problem 5. Seventh degree with 5 terms. I was going to have Haley help me with problem 5. Yeah.
Me close the door.
You've missed a lot while you were sleeping. You missed the whole back end of the notes, and then we were doing the homework together right now. Just FYI. It is not a constant, and the reason it's not a constant is because of what I'm putting a little circle around. If it has any variables in it at all, it doesn't have a chance to be a constant. The word variable means can be varied. Like if something is like the variable temperature, that means it's going to change, right? And variables, when you change the value, then you change the what it equals. So if it's got a variable, you can't say constant. What's his degree, Haley? No, linear would be if his degree was 1. What's this guy's degree? Hint, hint, right there. Yes. 4th degree means it is definitively a quartic. And how many terms does he have? You can't have 0 terms. You got to have at least 1. And this is just 1 term, so we call this a quartic monomial. Quartic because of the x to the 4th or n to the 4th, whatever. Monomial because there's just 1 chunk of junk, no pluses, no minuses. Sound good? Yeah. Okay. I'm going to be calling on you again just for your information, okay? Number 6. Tough. What do you think, my man? Number 6. Yeah, you've got this down pretty well, don't you? So the linear comes from the fact that this is negative 3b to the power of 1. You don't see the 1, but it's there. So linear, and you said what? Monomial. Very good. Good. Let's head over to Trinity. Tell me about problem 7. So weird. I'm sorry, one more time, go ahead. And then we need to, yeah, for sure. Get that constant term there at the end. So good job with getting it into standard form. And now, Trinity, we have to classify this bad boy. What would you say he is? Quartic, very good. Quartic with 4 terms. Well played. Nice job. It was a good patient process there. Let's head over to problem 8. I'm coming back to you there, Haley. So could you help me out here? The first thing we got to do is get it in standard form. So what's that going to look like? Great. Good job with your standard form. Now you got to help me classify this bad boy. The good thing about putting it in standard form is that the degree you're looking for will always be at the beginning now if you did your standard form correctly. So what's his degree? Good job. He's a quintic. And based on the number of terms, what would you say he is, Haley? Crushed it. Much better than that last time. Great job. Quintic binomial. Good job. I think that's going to be it for me interacting with you because it's 3:38. And yes, these will be due tomorrow so that tomorrow we can move on and start something else. Really, we did the first 8 problems together, which I think leaves you with 16 to go that should not take very long, right? So that is that.